Hi, welcome to Physics Teacher, a channel that prepares you for the Waterloo Math and Science Contest. This is a grade 10 Math Galois contest question. It's question number 4, which is the last question in the year 2021. There are 3 parts, the last part culminating in trying to find all possible values for p, which is a prime number greater than or equal to 5, for which both x and y are positive integers. Give it a try, and I'll be right back with the solution. Alright, so we're going to start with part A. Part A is fairly easy. We have this equation 5 over x plus 14 over y equals 2. And they're saying if x equals 6, what is y? So we're just going to substitute 6 in for x. So we have 5 over 6 plus 14 over y equals 2. If we bring our 5 over 6 to the other side of the equation, we have 14 over y equals 2 minus 5 over 6. And now we need to subtract. You can think of this 2 as 2 over 1. And so we have 14 over y equals, now 2 over 1 is the same as 12 over 6. And 12 minus 5 is 7. So we have 7 over 6. Alright, so we can see that, well, 7 times 2 is 14. So 6 times 2 tells you that y equals 12. So there's our answer to part A. Alright, so let's move on to part B. Part A was a good introduction to the question. I think most grade 10 students can answer it, and it'll give you a little bit of a confidence before part B sort of whacks you down a bit. It's not as easy. So we have this equation, 4 over x plus 5 over y equals 1. And we need to find out all pairs of positive integers x, y that would be a solution to this problem. Alright, so let's analyze this equation a little bit first. So we have 4 over x plus 5 over y. And that is going to equal 1. So what I'm going to do is first multiply everything by xy, which would be our common denominator here. So we have 4 over x times xy plus 5 over y times xy. That's going to equal 1 times xy, which is just xy. Alright, so over here our x's will cancel, and we have 4y. Over here our y's cancel, and we have 5x. And that's still going to equal xy. So let's bring these terms to the other side of the equation. So we'll have xy, and then minus 4y minus 5x. And that'll all equal to 0. Now, in our first 2 terms, we can pull out a common factor y. Now, with these 2 terms here, we have a common factor x. Let's pull that out. So we're going to have x times y minus 5. And then we still have this minus 4y here. Now what I can do is I can add 20 to both sides of the equation. And the reason why I'm going to do that, so let me show you. So you have minus 4y. If I add 20 to this side, and therefore I have to add 20 to the other side of the equation, then I can pull out a common factor here. And let me continue over here. The common factor there is going to be 4. So we have x times y minus 5. And if I pull out, I'll pull out a negative 4 actually. Then we're left with y minus 5. And that's going to equal 20. So I have a like term here of y minus 5. And I can get x minus 4 times y minus 5 is going to equal to 20. Now, since x and y are both positive integers, that means x minus 4 and y minus 5 are also integers. Not necessarily positive. But since their multiple equals 20, that means they're both integers that are a factor or factors of 20. Now, we do know that y, let's start with y. So y is a positive integer, so it's going to be greater than 0. Now, if I subtract 5 from both sides, I can say y minus 5 is going to be greater than negative 5. So what I want to look at for this term y minus 5 is all the factors of 20 that are greater than negative 5. Now you're going to have, let me write all the factors up here. We're going to have negative 4, negative 2, negative 1, 1, 2, 4, 5, 10, and 20. So those are all integers, which are factors of 20 that are greater than negative 5. However, you can test this yourself, but these negative integers won't actually work, and here's why. Let's say y minus 5 is negative 4. That means that x minus 4 would have to be negative 5 for this equation to be true. And if x minus 4 is negative 5, that would mean x has to be negative 1. But that can't happen because x and y are positive integers. And this is true for all of these negative values. So the only ones we're going to be interested in are these factors of 20. So I'm going to keep these factors of 20, but I'm going to free up some room here. Alright, and I'm going to create a chart. So in this chart, I'm going to have our factor pair, which will give us 20. For example, one factor pair would be, 1 and 20. So 1 times 20 will give us 20. Then I'm going to look at what this x minus 4 would be. And I'm going to look at what that y minus 5 would be. And then solving those, we're going to have to figure out what x and what y are going to be. Because that's what the question is asking, for all positive integers x and y that are solutions. Alright, so if we're to start with this factor pair, well, one of them would have to be 1 and the other one would have to be 20. And of course, we would have to do 20 and 1 as well. So 1 would be 20 and 1 would be 1. Alright, so if x minus 4 equals 1, we can rearrange that to solve that x then would have to be 5. And if y minus 5 is equal to 20, we can rearrange that to say y would have to be 25. And if we did the same thing here with 20 and 1, well then x would have to be 24 and y would have to be 6. So there's two possible solutions for us right there. Now we have to look at all the other factors pairs. So another factor pair would be, for example, 2 and 10. So we're going to do 2 and 10. Then we're also going to have to do 10 and 2. Then another factor pair would be 4 and 5. So we'll do 4 and 5. And then of course also we're going to have to do 5 and 4. And I can just go through and finish this chart here. And there we have it. So we have 1, 2, 3, 4, 5, 6 different solutions for our pair of positive integers x, y. Alright, let's move on to part C. Part C is similar to part B, you can tell with the equation, and we're going to start by solving it very similarly. So let's look at 16 over x plus 25 over y is equal to p, where p is some prime number greater than or equal to 5. And we need to find all possible values of p, for which there is at least one ordered pair x and y, where x and y are again positive integers. So let's rearrange the equation just like before. I'm going to multiply every term by the common denominator, which is xy. So we have 16 over x times xy plus 25 over y times xy. And then on the right side of the equation, we have pxy. Alright, so our x's are going to cancel here, and we'll get 16y. Our y's will cancel here, so we'll have plus 25x, and that'll all equal pxy. Now, just as before, I'll bring these terms to the other side of the equation, so we have pxy minus 25x minus 16y, and that's going to equal to 0. Now what I'm going to do next is a little different. I'm going to multiply every term by p. So that's going to give me p squared xy minus 25px minus 16py, and that is all going to equal 0, because 0 multiplied by some integer that's not 0 is just 0. And I know that p is not 0 because it says p is greater than or equal to 5. So now what I can do is I can pull out a px from the first term, which leaves me with py minus 25. Then I have this minus 16py. Now because I want to pull out this same factor here, well, 16 times 25 is 400. So I'm going to add 400 to both sides of the equation in order to do that. So let's continue up here. So now I have px times py minus 25. And then here I can pull out a minus 16, which is going to give me py minus 25 again. And that's all going to equal, I'm going to put it on this side because I've run out of room, 400. Alright, so I have the same factor here, py minus 25. So I can pull that out and I'm going to be left with px minus 16 times py minus 25, and that is going to equal 400. Now, just as before, because p, x, and y are all positive integers, that means that px minus 16 and py minus 25 are also integers and are factors of the number 400. Now I know that p has to be greater than or equal to 5. I also know x has to be greater than or equal to 1, which would mean that px must also be greater than or equal to 5. And if I subtract 16 from both sides, we'll get px minus 16 must be greater than or equal to negative 11. So when looking at all the factors of 400, which are greater than or equal to negative 11, we do get some negative factors. For example, we would get negative 1, negative 2, negative 4, negative 5, negative 8, and negative 10. But just as in part B, if you were to use any of these negative factors for here, you would be forced to make either p or y negative numbers in this term in order to satisfy the equation. So just as in part B, and you can try them yourself, our negative factors are not going to work. So let's create a chart for all the positive factors like we did in part B. And so let me give myself some room here. So in this chart, we're going to have our first factor, our px minus 16. So that's our first factor of 400. Sorry. And then we're going to have our second factor, py minus 25. And then I'm going to solve for px and py instead of solving for x and y because it's a lot easier to solve for px and py. And then once I've solved for px and py, I am going to look for a common prime factor among them. So what do I mean by that? Let's take an example. The easiest one to think of for our factors of 400 would be 1 and 400. Right? 1 times 400 is 400. So that means if px minus 16 is equal to 1, that would mean that px must be 17. And if py minus 25 is equal to 400, that means py must be 425. Now 17 is a prime number in and of itself, but if you look at 425, it's equal to 17 times 25. So there's a common prime number between them. And therefore, it is perfectly possible for p to be 17. Because in this case, x would be 1 and y would be 25. So both x and y are integer, positive integers, and we have a common prime. So a possible solution for p, which is also an integer greater than or equal to 5. So we found one solution. Right? But we need to find all the solutions. So we need to continue this chart to see what all the possible solutions would be. Alright, so when we're done our chart, we see that there's 1, 2, 3, 4, 5, 6, 7 possible values for p. Hope you enjoyed the question, and if you want to see more, please consider subscribing.